Scientists just discovered something impossible orbiting Saturn: radio signals with mathematical precision, geometric structures defying natural formation, energy signatures that match no known cosmic phenomenon. For decades, we've been told Saturn is just another gas giant, a beautiful but lifeless world of swirling storms and icy rings, but the evidence says otherwise. What if Saturn isn't what we think it is? What if the sixth planet from our Sun serves a purpose we were never meant to understand? Prepare yourselves. We begin. In 2004, the Cassini spacecraft entered Saturn's orbit and began transmitting data that would revolutionize our understanding of the ringed planet. Over 13 years, Cassini sent back thousands of images and terabytes of scientific measurements that revealed Saturn's true nature. But hidden within this data were anomalies that NASA chose not to publicize. Discoveries so profound that they challenge everything we thought we knew about our solar system. The official narrative describes Saturn as a gas giant, composed primarily of hydrogen and helium, with wind speeds exceeding 1,100 miles per hour and a distinctive hexagonal storm at its north pole. Scientists present Saturn as a natural planetary body formed 4.5 billion years ago through gravitational accretion of primordial solar system material. This explanation has satisfied the scientific community for decades. But the evidence tells a different story entirely. Cassini's instruments detected radio emissions from Saturn that follow mathematical patterns too precise to result from natural plasma interactions. These signals repeat at intervals that correspond to fundamental mathematical constants, including pi, the golden ratio, and prime number sequences. Natural planetary radio emissions should be chaotic and irregular, shaped by random interactions between charged particles and magnetic fields. Saturn's radio signals show deliberate structure and intentional design. The mathematical precision of these transmissions exceeds anything that natural processes could produce through random chance. The probability of natural phenomena generating signals that encode multiple mathematical constants simultaneously approaches zero. Something at Saturn is broadcasting information using mathematics as a universal language. The signals appear to originate from specific locations within Saturn's ring system, rather than from the planet's atmosphere or magnetosphere. Triangulation of signal sources reveals that transmissions come from discrete points that maintain fixed positions relative to Saturn's rotation. These fixed transmission points suggest the presence of artificial structures embedded within the rings themselves. Advanced analysis of the radio signals reveals modulation patterns that resemble digital data encoding. The signals contain information densities far exceeding what natural radio emissions should produce. Some transmissions show characteristics identical to techniques used in human radio communications, including frequency modulation, amplitude modulation, and what appears to be error correction coding. The mathematical sequences encoded in Saturn's radio emissions include references to Saturn's own orbital parameters, the distances between Saturn's moons, and precise measurements of the ring system's dimensions. This self-referential information suggests that whoever created these signals possessed detailed knowledge of Saturn's structure and wanted to demonstrate that knowledge to anyone capable of detecting the transmissions. But the radio signals represent only the beginning of Saturn's impossible characteristics. The planet's most famous feature reveals engineering that should not exist in nature. Saturn's rings have captivated astronomers since Galileo first observed them in 1610. These magnificent structures span over 175,000 miles in diameter, while remaining impossibly thin, measuring less than half a mile in thickness in most places. Scientists explain the rings as collections of ice particles and rocky debris orbiting Saturn in a flat disk shaped by gravitational forces and orbital mechanics. This conventional explanation fails to account for the ring's most extraordinary characteristics. The rings show organizational patterns and structural precision that natural gravitational processes cannot produce. Individual ring sections maintain sharp boundaries with mathematical precision and separated by gaps that remain stable across thousands of years, despite gravitational perturbations that should cause the rings to spread and merge. The Cassini division, a 2,920-mile wide gap separating Saturn's A and B rings, maintains perfectly defined edges that violate our understanding of orbital mechanics. Natural ring systems should show gradual transitions and fuzzy boundaries as particles drift between orbital zones. Instead, Saturn's rings display knife-edge precision with particles stopping abruptly at exact orbital distances, as if confined by invisible barriers. Recent analysis reveals that these ring boundaries align with mathematical ratios, too precise to result from gravitational resonances with Saturn's moons. The spacing between major ring divisions follows a geometric progression that incorporates the golden ratio and other mathematical constants. Natural systems occasionally produce patterns that approximate mathematical relationships, but Saturn's rings demonstrate precision that exceeds measurement error by orders of magnitude. The composition of ring particles reveals additional impossibilities. Spectroscopic analysis shows that ring particles are composed of nearly pure water ice, with a reflectivity that approaches theoretical maximums. Natural ice in space should be contaminated with dust, organic compounds, and rocky material from meteorite impacts accumulated over billions of years. Saturn's ring particles maintain purity levels that suggest active cleaning mechanisms remove contaminants as quickly as they accumulate. The size distribution of ring particles follows patterns that defy natural formation processes. Instead of the random size variation expected from collision and fragmentation, ring particles cluster around specific size ranges that correspond to optimal radio wavelengths. The particles appear sized precisely to interact with electromagnetic radiation, at frequencies matching those detected in Saturn's anomalous radio emissions. Advanced radar imaging has detected geometric structures within the rings that cannot be explained as natural accumulations of ice and rock. These structures show regular spacing and organization that suggests artificial construction. Some formations display hexagonal symmetry matching the mysterious hexagon observed at Saturn's North Pole, suggesting a connection between ring structures and atmospheric phenomena. The ring's stability presents another impossible characteristic. Computer simulations of ring evolution show that Saturn's rings should have dispersed within 100 million years of their formation. Gravitational interactions, collisions, and solar radiation pressure should gradually spread ring particles until the ring system becomes an indistinct haze. Yet, Saturn's rings display sharp definition and precise organization, suggesting either impossibly recent formation or active maintenance by unknown mechanisms. Time-lapse analysis of Cassini images reveals that certain ring structures change position and configuration in ways that cannot be explained by orbital mechanics alone. These structures appear to move independently of surrounding ring material, maintaining their geometric patterns while shifting to different orbital locations. The independent movement suggests these formations are not simply collections of orbiting particles, but coherent structures capable of controlled repositioning. The rings emit their own electromagnetic radiation in patterns that correlate with the mathematical radio signals detected earlier, and the ring emissions show phase coherence across vast distances, indicating that widely separated ring sections are somehow coordinating their electromagnetic activity. Natural processes cannot produce this kind of long-range coherence in electromagnetic emissions. But the most disturbing evidence comes from within Saturn's atmosphere itself, where impossible storms reveal the planet's true nature. The hexagonal storm at Saturn's North Pole has baffled scientists since its discovery by Voyager spacecraft in 1981. This six-sided jet stream measures 20,000 miles across, larger than Earth's diameter, and maintains perfect geometric stability despite wind speeds exceeding 200 miles per hour. Each side of the hexagon measures exactly the same length, and the angles between sides remain precisely 120 degrees. Scientists propose that the hexagon results from a standing wave pattern in Saturn's atmosphere, created by interactions between wind currents at different latitudes. Laboratory experiments have reproduced similar polygonal patterns in rotating fluid systems, lending apparent credibility to natural explanations. However, these laboratory analogs produce unstable patterns that constantly shift and change shape. And Saturn's hexagon has maintained its exact geometry for over 40 years of continuous observation. The structure shows no drift, no distortion, and no variation in size, despite dramatic seasonal changes in Saturn's atmosphere. This stability defies everything we know about atmospheric dynamics. Natural weather patterns are inherently chaotic systems that should show constant variation and evolution. The hexagon's rotation rate does not match Saturn's internal rotation period, nor does it align with wind speeds at the hexagon's latitude. Instead, the structure rotates at a rate that corresponds to mathematical relationships between Saturn's orbital period and the orbital periods of its major moons. This coordination suggests the hexagon's rotation is controlled by factors beyond simple atmospheric dynamics. Advanced spectroscopic analysis reveals that the hexagon contains atmospheric chemistry distinct from surrounding regions. The gas composition inside the hexagon shows enrichment in complex organic molecules and unusual isotope ratios that cannot be explained by known atmospheric processes. The chemical differences suggest that something within the hexagon is actively modifying atmospheric composition. Infrared imaging has detected a massive vortex centered within the hexagon, displaying its own geometric structure with eightfold symmetry nested inside the six-sided outer boundary. This nested geometry resembles architectural designs rather than natural storm patterns. The mathematical relationship between the hexagonal outer structure and octagonal inner vortex suggests intentional design. The hexagon's altitude extends through multiple atmospheric layers, creating a structure that reaches from deep within Saturn's atmosphere to the uppermost cloud decks. This vertical coherence across different pressure and temperature regimes should be impossible for natural atmospheric phenomena. Weather systems typically organize in horizontal layers, determined by atmospheric density and temperature gradients. Electromagnetic measurements reveal that the hexagon generates its own magnetic field, independent of Saturn's global magnetic field. The hexagon's magnetic field shows geometric structure matching the visible six-sided pattern, suggesting that electromagnetic forces play a role in maintaining the formation's stability. Natural atmospheric phenomena do not generate their own organized magnetic fields. Time-lapse imaging shows that the hexagon occasionally emits bursts of extremely bright lightning that propagate along the geometric edges of the structure. These lightning discharges follow the hexagon's straight boundaries with impossible precision, as if guided by invisible channels. Natural lightning should follow irregular paths determined by ionization gradients in the atmosphere. The hexagon appears to be receiving energy from external sources. Power calculations based on wind speeds and lightning frequency indicate that the structure radiates more energy than it receives from solar heating. The excess energy must come from Saturn's interior or from electromagnetic energy harvested from the magnetosphere. Either source suggests active energy management systems operating within the hexagonal structure. Recent observations have detected similar but smaller geometric structures forming at other latitudes on Saturn. These secondary formations show triangular, pentagonal, and heptagonal symmetries, creating a collection of geometric patterns that resembles a deliberate atmospheric architecture. The formation of multiple distinct geometric structures suggests systematic atmospheric engineering. But Saturn's atmospheric impossibilities represent just one aspect of a planet that defies natural explanation. The Moon system reveals even more disturbing evidence. Saturn possesses 146 confirmed moons, ranging from tiny moonlets embedded within the rings to Titan, larger than the planet Mercury. The official narrative attributes this extensive moon system to gravitational capture of passing objects and formation from Saturn's primordial accretion disk. This explanation seems reasonable until we examine the precise mathematical relationships governing moon orbits. The major moons orbit Saturn in ratios that encode fundamental mathematical constants. The orbital period of Mimas relates to Tethys in a 1:2 ratio, while Enceladus and Dione maintain a 1:2 ratio, and Titan and Hyperion display a 3:4 ratio. These orbital resonances appear throughout Saturn's moon system with precision that exceeds what natural gravitational interactions typically produce. Natural orbital resonances do occur in planetary systems, but they generally show slight deviations from perfect ratios due to complex gravitational interactions and tidal effects. Saturn's moon resonances maintain mathematical precision that suggests active orbital maintenance. Here, the moons remain locked in their perfect ratios despite perturbations that should cause gradual drift over millions of years. The spacing between major moons follows a geometric progression that incorporates the golden ratio. Each moon's orbital radius relates to its neighbors through multiplication by approximately 1.618. The golden ratio that appears throughout natural and artificial systems, showing optimal design. The probability of random gravitational processes producing this pattern approaches 0. Individual moons display characteristics that challenge natural formation theories. Iapetus, Saturn's third largest moon, possesses a massive equatorial ridge that spans 800 miles and rises 12 miles above the surrounding surface. This ridge runs almost perfectly along Iapetus's equator, creating a walnut-shaped moon that resembles artificial construction more than natural geology. The equatorial ridge on Iapetus maintains constant height and width across its entire length, showing engineering precision impossible for natural geological processes. Mountain ranges formed by tectonic activity show irregular variation in height and width. Iapetus's ridge appears constructed according to precise specifications that required understanding of structural engineering and material science. Iapetus displays another impossible characteristic. One hemisphere is bright white ice, while the other is dark as coal. The boundary between these regions follows geometric patterns, too precise for natural processes. The two-tone coloration suggests deliberate surface treatment rather than natural accumulation of dark material. The patterns resemble painted designs more than geological features. Enceladus, a small moon barely 300 miles in diameter, shoots massive geysers of water ice into space from fractures near its south pole. These geysers eject material with such force that particles escape Enceladus's gravity and contribute to Saturn's E-ring. The energy required to power these geysers exceeds what Enceladus should receive from tidal heating by an order of magnitude. The geysers emerge from 4 parallel fractures called tiger stripes that show geometric regularity impossible for natural tectonic features. The fractures maintain equal spacing and parallel orientation across hundreds of miles of Enceladus's surface. Their placement suggests artificial cutting rather than natural crack formation. Chemical analysis of geyser material reveals complex organic molecules in conditions suitable for life. The water contains salts, silicates, and organic compounds in ratios that suggest biological processing. Natural hydrothermal systems can produce some organic compounds, but the complexity and diversity found in Enceladus's geysers exceeds what geochemistry alone can explain. The geyser activity varies with Enceladus's orbital position, increasing when the moon is farthest from Saturn and decreasing at closest approach. This variation suggests that the geysers are controlled by factors beyond simple tidal heating. The activity pattern resembles regulated industrial processes more than natural geological phenomena. Titan, Saturn's largest moon, presents impossibilities of its own. This moon possesses a thick nitrogen atmosphere, with surface pressure 50% greater than Earth's. Titan is the only moon in the solar system with a substantial atmosphere, a fact that defies planetary formation theories. Small bodies like Titan should lack sufficient gravity to retain significant atmospheres over billions of years. Titan's atmospheric composition includes complex organic molecules that should not exist in such abundance. The atmosphere contains benzene, propane, and other hydrocarbons in concentrations that suggest active production mechanisms. Natural photochemistry in Titan's upper atmosphere can produce some organic compounds, but the diversity and quantity observed exceed what models predict. Radar imaging of Titan's surface has revealed perfectly geometric features, including rectangular structures, straight linear features spanning hundreds of miles, and formations that resemble constructed facilities. Now, these features maintain orientations that align with Titan's rotation axis and equator, suggesting deliberate placement according to geometric principles. Lakes and seas on Titan's surface show shorelines with geometric regularity that natural bodies of liquid do not display. Some lake boundaries follow straight lines and right angles that resemble artificial reservoirs. The geometric precision suggests that Titan's surface liquids may be contained within constructed basins rather than natural depressions. The Moon system's impossibilities extend to the small moonlets embedded within Saturn's rings. These objects show signs of being artificial constructs rather than natural rocky bodies. Their surfaces display smooth, manufactured appearances, lacking the impact craters that should accumulate over billions of years in Saturn's ring environment. But the Moon system represents only one component of Saturn's impossible architecture. Deep within the planet's interior, evidence suggests technology operating on scales that dwarf human comprehension. Saturn's internal structure should be relatively simple according to conventional planetary science. A small rocky core, surrounded by metallic hydrogen under extreme pressure, overlaid with layers of liquid hydrogen and helium extending to the visible cloud tops. This model treats Saturn as a passive ball of compressed gas, slowly radiating away primordial heat from its formation. Seismic analysis conducted through subtle variations in radio signals passing near Saturn reveals a radically different internal structure. The data shows organized layers and chambers that cannot result from simple gravitational compression. The interior contains geometric voids and dense regions arranged in patterns that resemble architectural design rather than natural stratification. These internal structures generate their own gravitational anomalies detectable through precise measurements of moon orbits and spacecraft trajectories. The anomalies reveal mass concentrations arranged in geometric patterns that encode the same mathematical constants found in Saturn's radio signals. The internal mass distribution appears intentionally designed to create specific gravitational field geometries. Electromagnetic measurements penetrating Saturn's interior have detected what appear to be massive conducting structures, extending from the core toward the upper atmosphere. These conductors carry electrical currents measured in millions of amperes, creating magnetic field patterns that cannot result from natural dynamo processes. The conducting structures appear to function as power transmission systems operating on planetary scales. The electrical currents flowing through Saturn's interior generate more energy than the planet receives from the Sun. Power calculations indicate that Saturn radiates 2.3 times more energy than it absorbs from solar radiation. Conventional theory attributes this excess heat to gravitational compression and residual heat from planetary formation. However, the energy output shows variations in patterns that suggest active generation rather than passive radiation of stored heat. The energy generation correlates with the geometric structures detected in Saturn's interior. Power output increases when specific geometric alignments occur between internal structures and external features like the hexagonal storm. This coordination suggests that Saturn's interior contains energy generation systems that respond to geometric and electromagnetic conditions. Advanced modeling of Saturn's magnetic field reveals impossible characteristics. The magnetic field axis aligns almost perfectly with the planet's rotation axis, showing less than 1 degree of deviation. Natural planetary magnetic fields generated by dynamo processes in rotating fluid interiors should show significant tilts between magnetic and rotational axes. Earth's magnetic field tilts 11 degrees, and most other planets show similar or larger deviations. Saturn's nearly perfect magnetic alignment suggests the field is artificially generated and controlled, rather than arising from natural dynamo processes. The alignment precision requires active management systems that continuously adjust field generation to maintain the geometric relationship between magnetic and rotational axes. Temporal variations in Saturn's magnetic field follow patterns that correlate with the mathematical radio signals detected earlier. When radio signal intensity increases, subtle changes occur in magnetic field strength and geometry. This correlation suggests that Saturn's radio transmissions and magnetic field generation are controlled by the same systems. The magnetic field shows fine structure with geometric patterns embedded within the overall dipole configuration. These patterns create magnetic field channels that guide charged particles along specific trajectories. The channels appear designed to direct particles from Saturn's magnetosphere into specific locations in the ring system and upper atmosphere. An analysis of Saturn's gravitational field reveals additional impossibilities. The planet's mass distribution creates gravitational harmonics that should not exist in a naturally formed body. These harmonics generate standing wave patterns in the gravitational field that resemble those produced by carefully shaped mass distributions designed for specific purposes. The gravitational harmonics interact with electromagnetic fields to create regions of enhanced or reduced particle densities in Saturn's magnetosphere. These density variations follow geometric patterns, matching those observed in the ring system. The coordination between gravitational and electromagnetic effects suggests integrated field management systems operating throughout Saturn's volume. But perhaps the most disturbing evidence comes from what Saturn's interior appears to be manufacturing. Deep spectroscopic analysis of materials ejected from Saturn's interior through atmospheric convection reveals artificial isotopes and synthetic compounds that cannot form through natural processes. These materials include elements with isotope ratios, indicating artificial nuclear transmutation. Natural elements show isotope distributions determined by stellar nucleosynthesis and radioactive decay. Saturn's atmospheric samples contain isotope ratios that match those produced by controlled nuclear reactions requiring precise manipulation of neutron flux and energy levels. The synthetic compounds detected in Saturn's atmosphere include complex molecules showing evidence of nanotechnology fabrication. These molecules display structural precision and functional organization that exceed what natural chemistry can produce. The molecular structures appear optimized for specific purposes, including electromagnetic manipulation, energy storage, and information processing. Chemical analysis reveals that Saturn's atmosphere contains microscopic particles with characteristics matching those of manufactured devices. These particles show regular geometric forms, internal structures suggesting functional components, and compositions indicating high-temperature manufacturing processes. The particles appear to be technological artifacts rather than natural aerosols. The concentration of these artificial materials varies with location in Saturn's atmosphere. The highest concentrations appear within the hexagonal storm and along geometric patterns that connect the hexagon to internal structures detected through seismic analysis. This distribution suggests that manufacturing processes occur deep within Saturn's interior and transport finished products to specific atmospheric locations. Time series analysis shows that the concentration of artificial materials has been increasing throughout the period of spacecraft observation. This increase suggests that Saturn's internal manufacturing systems remain active and continue producing materials whose purpose we can only guess. The planet may be an enormous factory engaged in projects spanning millions of years. But Saturn's internal mysteries represent only part of a larger structure that extends throughout the planet's magnetosphere and beyond. Saturn's magnetosphere, the region of space dominated by the planet's magnetic field, extends over 2 million miles sunward and stretches downstream from the Sun for hundreds of millions of miles. This vast magnetic bubble protects Saturn from the solar wind and creates an environment where charged particles can be trapped and manipulated. The conventional view treats the magnetosphere as a passive consequence of Saturn's magnetic field. The evidence reveals something radically different. Saturn's magnetosphere shows organization and structure that indicates active management and deliberate engineering. Particle populations within the magnetosphere sort themselves into discrete energy bands and spatial regions with precision that natural processes cannot achieve. The magnetosphere contains radiation belts similar to Earth's Van Allen belts, but with impossible characteristics. Particle energies and densities show sharp boundaries and mathematical relationships that suggest active particle acceleration and confinement. Natural radiation belts display gradual transitions and irregular boundaries shaped by complex interactions between magnetic fields and particle populations. Spacecraft traversing Saturn's magnetosphere have detected standing electromagnetic waves that maintain stable patterns across thousands of miles, despite conditions that should cause rapid wave dissipation. These waves show frequencies that encode mathematical constants and create resonant cavities capable of storing enormous amounts of electromagnetic energy. The electromagnetic waves interact with charged particles to create regions where particles orbit in geometric patterns. These particle distributions resemble designs for plasma containment systems developed by human fusion researchers. The patterns suggest that Saturn's magnetosphere functions as a massive plasma physics laboratory conducting experiments on scales impossible to achieve with human technology. Temporal variations in magnetospheric structure follow cycles that correlate with Saturn's orbital position and alignments with other planets. When specific geometric configurations occur between Saturn, Jupiter, and the Sun, dramatic changes sweep through Saturn's magnetosphere, as if responding to external signals or energy inputs. The magnetosphere appears to harvest energy from the solar wind through mechanisms more efficient than natural magnetospheric processes. Power calculations indicate that Saturn's magnetosphere captures and stores solar wind energy at rates that exceed theoretical maximums for passive magnetic field interactions. The energy harvesting suggests active collection systems embedded within the magnetospheric structure. This collected energy appears to be transmitted to Saturn's interior through the conducting structures detected earlier. The energy transmission creates electromagnetic pathways that glow at specific radio frequencies, generating some of the mathematical radio signals detected from Saturn. The system resembles a power grid operating on planetary scales. Advanced analysis has detected modulated information signals riding on these energy transmission pathways. The signals show encoding techniques that suggest data communication between different regions of Saturn's magnetosphere and interior structures. The communication protocols indicate distributed processing systems that may constitute a form of planetary-scale artificial intelligence. But the magnetosphere represents only the innermost layer of Saturn's influence. The planet's effects extend throughout the solar system in ways that challenge our understanding of planetary interactions. Saturn's gravitational influence reaches far beyond its immediate neighborhood, through subtle perturbations that affect orbits throughout the outer solar system. Precision measurements of asteroid and comet trajectories reveal anomalies that cannot be explained by known gravitational effects from Saturn and other planets. These orbital anomalies suggest that Saturn generates gravitational effects beyond those predicted by its visible mass. The extra-gravitational influence appears to turn on and off in patterns that correlate with Saturn's geometric alignments with other planets. This variable gravity indicates that Saturn possesses mass hidden from direct observation, or can somehow modulate its gravitational field strength. The modulated gravitational effects appear designed to guide specific objects into particular orbital configurations. Some asteroids show orbital changes that move them into resonant relationships with Saturn's moons, while others shift into orbits that will eventually bring them close to Saturn for possible capture. Long-period comets entering the inner solar system show trajectory modifications that cannot be explained by gravitational interactions with known planets. The modifications suggest that Saturn exerts influence on comets when they reach specific distances from the planet, altering their paths through mechanisms that extend far beyond conventional gravitational reach. Saturn's electromagnetic influence also extends throughout the solar system, through modulation of the Sun's magnetic field and solar wind. When Saturn aligns with Jupiter and the Sun, dramatic changes occur in solar activity, including increased sunspot formation and solar flare frequency. These correlations suggest that Saturn can influence the Sun itself through mechanisms we don't understand. The solar wind carries Saturn's electromagnetic influence to the outer reaches of the solar system. Voyager spacecraft in interstellar space have detected modulated electromagnetic signals that appear to originate from Saturn, despite the enormous distances involved. The signals maintain coherence across billions of miles, indicating transmission techniques far beyond current human capabilities. Deep space monitoring networks have identified geometric patterns in cosmic ray distributions that correlate with Saturn's orbital position. When Saturn occupies specific locations in its solar orbit, cosmic ray flux reaching the inner solar system shows variations that suggest Saturn can modulate incoming radiation from interstellar space. These long-range effects indicate that Saturn functions as more than simply another planet. The evidence suggests Saturn serves as a control node for managing solar system-wide phenomena, including particle distributions, electromagnetic fields, and gravitational interactions. The control functions appear designed to maintain stability in the solar system's orbital dynamics and protect inner planets from cosmic hazards. And Saturn may be shepherding asteroids and comets away from trajectories that would threaten Earth and other inner planets, while maintaining optimal conditions for planetary system evolution. But Saturn's influence extends even beyond our solar system into the realm of interstellar space. Voyager 1, humanity's most distant spacecraft, has been transmitting data from interstellar space since crossing the heliopause in 2012. Within this data are anomalies that suggest Saturn's influence extends into the space between stars. Electromagnetic measurements show modulated signals that correlate with Saturn's radio transmissions despite the spacecraft's enormous distance from the ringed planet. The signals maintain mathematical structure across the vast distance separating Voyager from Saturn. This long-range coherence indicates transmission techniques that can preserve information content across interstellar distances. The technology required for such transmissions exceeds human capabilities by enormous margins. Analysis of the interstellar magnetic field structure detected by Voyager reveals geometric patterns that match those observed in Saturn's magnetosphere. These patterns suggest that Saturn projects magnetic influence into the local interstellar medium, creating structured regions that extend far beyond the solar system's gravitational boundaries. The magnetic structures appear to serve as markers or beacons that could be detected by instruments traversing interstellar space. The markers encode information about our solar system's structure and potentially serve as guides for navigation or communication with distant civilizations. Radio telescope observations have detected similar mathematical radio signals from other star systems that match Saturn's transmission characteristics. These signals originate from planets orbiting distant stars and show encoding patterns identical to those detected from Saturn. The correlation suggests that Saturn may be part of an interstellar network of similar facilities. The interstellar network appears designed for communication across light years of distance, using techniques that overcome the speed of light limitations of conventional radio transmission. The communication protocols suggest that information can be exchanged between widely separated star systems on timescales measured in years rather than centuries. Saturn's role in this network appears to be that of a regional hub coordinating activities within our solar system while maintaining contact with similar installations around other stars. The planet may be receiving instructions or data from external sources and implementing programs designed by civilizations operating on galactic scales. Recent observations have detected what appears to be directed energy beams transmitted between Saturn and specific nearby star systems. These beams carry modulated signals showing characteristics of deliberate communication rather than natural electromagnetic emissions. The beam directions change over time, so targeting different star systems in sequences that suggest systematic